Yeah, that's about it. Your surname was?
Badenhorst.
Goodness,
Badenhorst.
Badenhorst. How's it, guys, and welcome back to another episode of Burton Builds. Today we are talking about carbon fiber, and we are talking about carbon fiber with Martin Badenhorst, I think it is.
Yeah.
Is that correct? Martin is kind of from the university, but not really. He works for subcontracted something.
It's a company up in Joburg, but I'm actually finishing up there now too.
Okay, so your qualifications, what are just? It doesn't have to be anything with this, but what is it?
I've got a master's degree in mechanical engineering, and that focused basically on composites.
Okay, I went to school. That's where I finished. No, so you are a quite clever thing, I would say. You've got a fair amount of knowledge.
Done the time.
Yeah, you've done the time. So Martin has joined us today. I've been interested in making some carbon fiber stuff. Now, I've done this in the past before, not with carbon fiber because I couldn't get my hands on any carbon fiber, but many years ago, I don't know, maybe probably 10 years ago, I was actually making little camera rigs. Now, there it is. Well, this is not quite the whole thing, but basically we were going to mount a camera on something like this, a little plate, and then this goes underneath a helicopter, an RC helicopter, not a real one, and then we go and fly a helicopter and we take aerial footage. This was before the time of commercial or consumer grade drones. They actually came out 2 years after that. So I was wanting to make carbon sheets out of this, and I can't actually find it. I was looking for it earlier, but yeah, I found the old one. But just to give you an idea of what we did is made this little thing. Now the important bit is this piece over there. You can see that's not quite carbon fiber, but it's just glass fiber. It's probably, I don't know, a millimeter, 1.5 mm thick. But that's basically what I did, and I think that's kind of what you've got here.
I think basically, yeah.
Yeah, except yours is a bit stronger.
Possibly.
So I have been interested in this for a while, and yeah, I thought I would just go and kind of find out about the process. I don't really want to waste money going through raw material after raw material and failing at what I do, although that's generally how you learn. You learn the hard way and you remember.
Yeah, that's true.
But yeah, so Martin decided, he agreed to come talk about it. So what we're going to do basically is we've got some video which we're going to kind of comment on, walk through. He's going to walk us through the steps of what we need to do, and we'll take it from there.
Perfect.
So we've got our video here. Basically, before we actually get started, this has been done already. Not me. Yeah, I just watched the process, but Martin, along with some of his work colleagues and another industry expert, they manufactured this piece of carbon sheet, and this was made for.
We're actually going to run tensile samples on this at the varsity. So from this, we're actually still going to cut out a few samples and then actually just use them in a prac basically for students.
Okay, cool. So yeah, that's what it's for. So I was quite honored and lucky enough to watch the manufacture of that. So let's get started. What is the first step?
Probably cutting the dry fabric, keeping that in a nice clean place, and then preparing a surface with a release agent.
Okay.
Usually doing that the day before, so you've got everything nice and ready.
We want everything ready so that you can put layer, next layer, next layer,
Completely.
next layer, and not kind of waste time, I suppose.
Yeah.
Even before that, just make sure you've got all the materials.
Definitely.
But that's part of the preparation process, I would imagine.
Yeah.
Like you say, if we're doing this the day before, you'll easily see, oh, well, I'm missing a piece of plastic or whatever the stuff is called.
Yeah, completely.
Okay, yeah. So the first thing, actually, it came up actually while we were making the sheet, is the surface that we're going to kind of lay our piece onto. In your opinion, what is kind of the best to use?
It depends what you're making. So for us, we just wanted a flat sheet, so something like glass would be ideal.
Okay.
Obviously, you want it to be nice and smooth and great, but I mean, if it's a really complex part, you generally have a mold machined,
Okay.
nice precision machined mold that you'd then apply release agent to.
Sure. You're talking about then for not a flat part.
Yeah. If you've got something with a lot of
Contour.
curves, or if there's a part that you've designed on the computer, you'd manufacture a mold for it if it's going to be made in carbon.
Okay, cool. Well, look, my first sheets are probably going to be flat, so I'll get some glass. So yeah, that was the first part of the process. Start of primary video. There we go. Oh, by the way, we're just watching the video here. Kind of a background thing. So something I noticed here is on the glass, or in this case, we're using a Perspex sheet because the surface finish wasn't that important.
It wasn't. Well, it's basically what we had, but for this, it'll work fine. Perspex sheet was close enough. Nice and smooth, and then obviously, basically the day before, we've applied the release agent and sealer in one, which would be this stuff here. So that basically you apply to the material. So once you lay your fabric on, you're not going to get a part that's completely stuck to it.
Okay, cool. So just having a closer look, this is, is this like a special brand or something?
Yeah.
Munch? Like Num?
Yeah, I don't know how to pronounce that.
What, Mekon?
Yeah, Mekon.
Mekon.
And that's an aerosol release agent and sealant in one. So depending on what you get different types of release agent as well. Some are really nasty and others quite nice like this to work with.
Okay. And, are these really expensive things? Not specifically this brand, but as a release agent?
I think composites in general can be reasonably pricey, but it, again, really depends on what your budget is.
Okay, cool. So, yeah, I'm not too sure how much this costs, but it is worth getting because you
need it.
Yeah, you have to have it. So, that's the release agent. And then I also saw there was like a kind of a border being stuck down. What is that?
So before we started, we've basically taken a strip of sealant tape, which is going to be used later because we're putting this in vacuum. So that's almost basically a strip of putty, kind of, if you want to call it that, like a really sticky...
Putty in a tape form?
Yeah, completely.
Okay.
In a tape form that we'd then stick to the surface just around the perimeter so that later on, once we finish laying the fabric, we can just remove that white film that we've got there, just to put the vacuum bag on so it sticks and seals quite nicely.
Okay, cool. So just carrying on with the video, I see the next thing that's coming up here is the
peel ply.
Peel ply, yeah. It looks like a sheet, really.
Yeah. So this you don't actually need to put down on the surface, at least not in the beginning. It depends on what sort of surface finish you want. So for us, because we're going to be making tensile samples, we're going to be bonding tabs on either side of the carbon sheet. So I wanted a surface that's generally kind of rough, and it depends on what your application is. If you want something that's really nice and glossy, then probably not a good idea to put this on the side that's going to be, visible with the outside side. But I wanted both sides to be the same, so we've got to put this. And if you don't put this on, then you get a really nice smooth finish. But if you do put this on, basically once your part comes out, you'll just peel this off, and it gives you a nice sort of rough,
like a textured finish.
Yeah, completely.
Okay. So there's a nice little close up of this stuff. Now it's quite difficult to see. It's basically just like I don't know, like fiberglass. It's not fiberglass sheet, but it reminds me of that, really. It's just a material, like a cotton.
It's just a material, yeah.
Okay.
So that's also going to soak up a bit of excess resin as well, which is quite nice. So obviously you want your part to have as little resin in as possible to get to a point where, high strength to weight ratio.
Oh, sure. Okay. So the resin, as you said, we want as little resin as possible, but of course we still want 100% coverage though.
Yeah, completely.
Okay. So that was the peel ply. The next part of the video, let's see what comes up here. Of course, as we can see, the gentleman, this guy's name, it was Onno
Satford.
So Onno's got a company in Jeffreys Bay, and he's kind of an industry expert on carbon fiber molding and that type of thing.
Yeah, he's brilliant at composites.
So he's been doing it, I take it he's been doing it many years.
Possibly longer than what I've been alive for.
Yeah, so he came to show us, give us some tips and tricks there. So he was just cutting the samples. Now, as Martin said, you can do this the day before. The next thing that's coming up here is I see he's putting on the carbon sheet.
Yeah, so that would be a dry sheet that he's basically putting on just of the fabric, and the type that we're using there is the sort of woven fabric. And please excuse the sample we've got; it is a bit falling apart. But you get different types of carbon. So the one that we're using specifically for the standard is this 2x2 twill weave, but essentially you've got toes of carbon, which is a couple of thousand little carbon fibers, each one's thinner than a human hair basically.
I don't know if we're going to be able to see that really.
Yeah, that's woven in a fabric.
Let's see there. So you can just about see the little, there we go, that's better. So there we go, that's carbon fiber well, a strand of carbon fiber, really.
Yeah, well, you call one sort of string a toe. Generally, it's what
toe.
Toe, and each carbon fiber, I suppose, in itself would be
one of these little like
tiny.
hairs.
Yeah, so basically, what you've got there is probably about 2,000.
Okay.
Or so of those things,
Strange,
and then that's basically where the strength comes in. While they like using carbon fiber, I suppose, for aerospace and things like that, is you can actually tailor the strength. So in that direction, she's really strong. But if you if we pull in the other direction, it's completely useless.
Okay.
And then
I see you've got some other little samples here.
Completely. So this again would be a series of toes, also arranged in a single direction. So this is unidirectional carbon, which it depends. You can tailor your orientation depending on how your stresses lie in the part or how your part's designed.
Okay, so you'll make it up of different layers. So looking at this, we've got carbon. You said toes, right?
Yeah.
So they're running, well, just depending on how I'm
These
holding
ones
it.
are basically running like that. They're interwoven though, so you've got over and under.
Whereas this piece is kind of just running
all in one direction.
And then you've got to create your layers. How do you want the strength
So I suppose that's where the engineering comes in. It depends on what your part requirements are.
Okay.
And I mean, most people generally would see this and think of carbon fiber being that woven thing, but
that's what I
get different forms.
Okay.
And then this one's really cool. It doesn't like compound curves too much, so curves in 3-dimensional space. But this is actually quite nice because this is a spread toe fabric. So for same thing, same toes, except just spread out, so a lot flatter. And actually, I think the beauty of this is you have less holes per unit area, so you actually got fewer places for resin to sort of pocket and pull in. So you can actually get an even lighter part. And it's got a really nice pattern. I don't know if...
I mean, this is really thin. So we'll get the same strength in a thinner product at less weight because there's less place for the resin.
Completely. Yep. You want to get enough resin, obviously, for the composite to work, and you don't want it to be starved, but at the same token, you want to get as little resin as possible, because if you've got something that's majority resin, then you're essentially sitting with a very heavy part.
Okay, sure. Which is likely what this.
I think that's basically just glue.
Pretty much. There might be 2 layers in here. So that's the layers that are going down. Now you can have multiple layers. You can have maybe 1 layer or 10 layers.
Again, depending. Like I think in this we just had most of our sheets being the same size, but it again really depends on what your part is.
Okay.
So the engineer would dictate that in a ply book recipe that would have different layers and different sequences at different directions or orientations.
Arno did talk a little bit about the resins.
Yes.
So we've got a couple of them here. The first one, this Secomin, I don't know. These are just random brands. We're not affiliated or associated with any of these brands. It's just this is what we happen to have. So this is an epoxy resin.
It's an epoxy-based resin.
Is that all it is? Just an epoxy-based resin. So you've got a mixed hardener with this?
Yes, right? Definitely.
Okay, and the hardener is also made by the same people, Secomin, but just this one in this case is a slow hardener. How long is this workable for?
It's a good few hours.
Okay. As opposed to say a fast hardener, what are we looking at there?
You've got more time basically to work with this. Obviously, as the name suggests,
yes.
But suppose if you're a beginner, slow hardener might be nice to work with, because you need to sort of work fast, especially if it's a large part or something. Lots of layers. It's over time the stuff generally starts to give off heat, and then it starts hardening, and you don't want that.
And the slow hardener compared to say a medium or a fast hardener, do they still take 24 hours to cure completely, or
no, much less?
So a faster hardener would be maybe 6 hours to cure, whereas versus a slow 24 hours.
I think the thing comes in more to when it starts going syrupy, because especially if you're pulling a vacuum or something, you want
it must be fluid.
Completely. You need it to be fluid to actually be like drawn out. So if it does start going hard quickly, then she battles a bit with that, and you end up having a heavy part again. It's not like steel that you could just remachine or try and save if it's
wrong or it's not 100% correct, it's complete
in the bin,
waste
basically.
Yes. Okay. So there's a little bit of a tip. Maybe use slow hardener. I'll remember that for when I'm initially making my first little bits and pieces.
When we started, we wasted a ton of resin by not working, I suppose, smartly and not really knowing what we were doing.
And so this kind of brings up a question now. How much resin do you mix? Do you kind of just like gauge it by eye, or is there a specific weight per cubic meter of sheet, or how do you know what
you generally work it out based on your sort of weight of cloth and the ratio that you want? You'll try and
then you measure it to that.
Okay,
completely. Okay, we're measuring by weight. the hardener and the resin to mix the correct ratio together?
You need that ratio as well, because otherwise you can, if you mix it incorrectly as well, like I said, part goes into the bin. We've had instances before where people haven't mixed things correctly, and then the part never really hardens, or
oh jeez. So yeah, I mean you got to be really careful. But and I see Arno was he was being very accurate with this. He wanted 300 grams and I think 81 grams was the numbers. You calculated these relative to the part that we were.
So you're mixing 100 to 27 in terms of your resin to hardener.
Okay, sure. So and then you just kind of mixed it in a little bucket, really, little swazzle stick there. It's quite important, I think, to wear gloves with this type of thing when you're working with solvents and resins.
I think from a safety perspective, and definitely it's just annoying if you get resin on your hands and then suddenly everything starts sticking, and I've done that a few times as well.
I can. I've had some of that before, not necessarily with paint, but I was working with PVC glue. Now that's nowhere near as bad as resin, but when that gets on your hands, then you're trying to deal with parts, and then it actually makes fingerprints on other parts.
Completely.
So wear gloves, and maybe have multiple sets of gloves. So once one set is maybe a little bit dirty, peel those off quickly, put another clean pair on.
Yeah, it would work if you.
Okay.
I think he's working really nicely, so he's kind of keeping his hands away from it. But someone like me would probably get very dirty and actually get the resin on their clothes. So it would be great.
So wear old clothes as well. And then as for pouring the resin, are we just kind of again, I take it goes with experience, but we're just putting a little bit of resin down?
Yeah, you want enough to be able to spread it and to saturate that first layer.
Okay.
So what we're going to try and do is, you're going to see he's going to spread it and try and get as many of the bubbles out as he can. And you want this bottom layer to be as saturated as possible, and then you always want to work up. So you're putting the most resin down at the bottom, and as you're putting your successive plies out, you want to basically saturate each new ply with the previous.
With the previous, but for the first layer, you're pushing it all the way through from top down.
You have to.
Okay.
Yeah. Make sure it's really in there.
And I see he's put quite a lot on, a lot of resin on. But if I remember correctly, you did make the comment that it doesn't matter if you've slightly got too much on, because then it comes up through the layers.
Yes.
So when the second layer was going on, then he kind of just put it on. He didn't put any extra resin on, and then he flattened it to see how much resin came through, and then
you can adjust accordingly.
Okay.
Based on what your needs are. And
I see he's really giving it a good, scraping. Well, actually, let's talk about this. So it was a question that came up or somebody made the comment. Really, do you want to use a brush? I think it was.
Yeah.
Like a paintbrush, really. And it's something that I haven't really thought about previously, but I mean, it makes perfect sense. When you're brushing, the bristles can come off, and then you've got bristles in your...
That's why spatula's nicer.
Okay, so recommended to use a spatula. I mean, really, if you don't have one of these, a credit card. Oh yeah, okay, true.
Credit card would work.
Yeah, I mean, this thing you could probably. This is just you go to your hardware shop.
Yep.
Really, just buy a spatula.
Hardware store.
Okay, and plastic. I mean, I'm assuming we don't want to be using like steel trowels or scrapers.
No, generally something like plastic soft would be
Okay, so use that. There's no bristles that can come off here. Some from previous experience when I've made stuff, if you are reusing this, make sure that all of the previous resin has been cleared off or cleaned off. Not that there's any dry chips.
So, because in your next lap you could have dry chips coming off into your wet resin, which would...
Well, then it's... Unless you can get them out nicely, it's pretty buggered.
Yeah.
Okay. That's a nice little tip there. And as we said, he's kind of, I don't know, he's just giving it a good work in, back and forth, back and forth, back and forth. I noticed there's a couple of bubbles that are coming up. You know why?
That's just trapped air in between the peel ply and the plastic.
And
it's basically in the laminate. But he's trying to work them out now. But again, the vacuum will take care of that later if there is anything that we've missed.
Okay, so it'll draw all of the air out. Yeah. Okay. No, well that's does make sense. Just as a recap, there's the peel ply down, the first carbon sheet, and now he's put on the resin basically. And he's working it in. After that, we just kind of putting each layer down.
Successive layers down.
Okay. Yeah. So successive layers, and then topping off or topping up with a little bit of resin.
Yeah.
As and when we need.
Just to make sure it's saturated.
Okay. We can basically see now the second layer of sheet going in. Now, this is, don't get us wrong here. This is one part we were making, I think.
Yes.
But I think there was a slight confusion in the beginning as to how it was going to be cut or how many samples were needed.
I changed my mind basically when you had cut these two sheets. Yeah,
okay, so the key thing here is we're not doing this for any reason.
Yeah.
But in that centerpiece is just to make sure that no samples are cut over that center joint.
Yeah. Obviously, we're cutting rectangles out, so we wouldn't want a rectangle with a weak gap in the middle.
Okay, sure. So having a look here, he's put those two sheets down. Now, in normal cases, this would just be a single sheet again.
Yes.
One whole sheet. He's worked it down. Now, some of it's changed color a little bit. It's got a little bit darker, obviously, as the resin is kind of pulled through. And you've just put a real small blob now.
Yeah.
On there. So that's what you were talking about, right? You're just putting what you need, really.
Just what you need, yeah.
Okay.
So you should work that through.
And we're working it the same way? Just
100%.
Cool. So
each one just needs to be saturated.
Man, I don't know why it's looking. I hate to say this, but it
looks
easier.
Really simple. Yeah,
it looks easier than what you would think. But I'm sure there's a lot of technique behind this to get really accurate and conformal pots, if you want to say.
I think this is a very basic way of doing it.
Something to remember: this is just flat sheet. Flat sheet is really easy to make.
And you also get different ways of doing it. So we're applying the resin with a pot, but you can get something like resin infusion where you draw the vacuum first, actually, and then you sort of release in it. The vacuum actually draws the resin in through a hose and spreads it through the material, and then you cut it off and put more in, and that keeps going through. So then you get really nice saturation. But again, it's a bit more of a complex technique.
Okay.
And it also depends on the application.
Sure. So I see this is the last layer that's going in. We wanted, or you wanted 3 layers. Is that correct?
I can't remember how many, but there are a few.
Whatever the calculation was, for the practical that was going to happen. In this case, it was 3 layers. I see the next thing going on here is peel ply.
So in an ideal world, if we had planned this properly, like I should have, then we would have actually had the peel ply and all of the fabric cut before, and we wouldn't actually be cutting this over. But
okay, sure.
So in an ideal world, we would have actually just taken the sheet on and laid it flat over there.
Okay.
And again, that's for surface finish and just to soak up any additional
excess.
Yeah, a little bit of excess resin.
Okay, sure. This kind of sounds like my cheap and nasty run and gun style manufacturing. Yeah. We think about things and then we change it once the project's like almost done.
Yeah.
But look, it does work. It's not. You can see we kind of holding the sheet up, cutting it, and then only putting it down. And I see it looks like the peel ply is cut. Is it the same size as the carbon, or is it smaller or larger?
Ideally, should be the same size. In this case, you can see the carbon's obviously a little bit bigger, but
I mean, our samples are being cut out of the center.
The peel ply section, yeah.
Yeah. Okay. So it's not really that important.
No, it's not important. And
so what are we seeing here? We're seeing it looks like some of the
resin's coming through.
Yeah, the resin. Yeah, that's right.
Yeah.
That's correct.
Yeah, that's 100% correct. So that's actually making sure that that's saturated as well. And
so what happens in this case where the resin is coming through, and once we've kind of got as much through as possible, if there's still patches that are light where you can see the resin hasn't come through, then do we apply resin on top of this?
You can. At the end of the day, what we're going to do after putting the peel ply on is we're going to put additional layers on that are going to remove even more resin. So if you're really worried about the surface finish, I suppose you could.
Okay.
You don't have to though.
Okay, cool. So yeah, looking again pretty simple. But again, these guys have been doing it for a couple of years. I have been doing it for all of 5 minutes. The next layer that's going on here, blue plastic. What is this?
This is basically a perforated film. That's a light blue plastic that helps us get the next layer off. So all that this does is it has a ton of tiny little holes in, and again, depending on what your needs are, you get different grades of the stuff. But we put this on top of the peel ply. So in our instance here, the peel ply is mainly for finish, although it does soak up a little bit of excess resin.
Okay.
But now your main resin that's going to come on with the next stuff is actually taken up by this stuff, which is called a breather bleeder. Okay. So as we put this on and the vacuum goes down, this film prevents that film from getting stuck to the actual laminate, and then the excess resin really gets soaked through these little holes. There
is a little square cut out in the bottom right hand corner. Anna was just demonstrating something to us.
Basically what happens if you don't put this stuff.
Okay, yeah. Spoiler alert, if you don't put it down, you bug it.
Yeah, it's not fun.
It doesn't come off. So this is quite important, this layer. And of course it's not, just remember, it's perforated.
It has to be
It has to be perforated, yeah. So I see that's being also flattened, just basically flattened as best you can.
You mentioned size earlier as well, so we're putting a breather bleeder down. So you want this to be either the same size as the part or preferably a little bit bigger.
Okay.
Because if this is bigger than this, she's going to get stuck again as if we didn't have this. So that makes logical sense, obviously, too.
Okay, so the breather bleeder. Now, this breather bleeder is, this reminds me of maybe that sisylation or that your stuff you put in your ceiling for insulation, but it's just really thin. Is it anything special, or is it just something it soaks up?
We just get it from the composite store, but essentially all that its job is just to take excess resin.
Okay,
it goes in the bin straight after the lab.
You know, I'm looking at this, and to me, I'll just go down to our material shop down the road here and just buy something that resembles this. Yeah. So as long, the main part about this is just to absorb the excess resin.
Yeah.
Once it's vacuumed, really. Okay. So breather bleeder. On top of, you said, what is it? Is there a technical name for this?
This is a release film.
Just a release film.
Yeah.
Okay. Again, we're cutting it on the site. That's to make sure of that it fits. Of course, if it looks like it's cutting skew, that it's cut straight. It's just lens distortion that you're seeing there.
Basically, our laminate should be done now, and then it's just putting the whole thing into vacuum. So what we're doing here as well is we're going to be connecting a vacuum hose to this. So we took a little piece of this and just folded it around and then laid that on top of this. So obviously this being a porous material allows us to get an even distribution of the vacuum across the whole part. If we didn't have that, we could use something like a gauze mat, or in the past, if we haven't used this, we've used something like a spiral band around the perimeter as well, just to actually make sure that your vacuum can spread across the whole part and not just be localized in one area. So you can't have, say, just the one corner in a vacuum and maybe a bubble down there. You need the vacuum to draw through.
And that would happen if you just had the piece of pipe sticking in. Is that
it's a possibility.
Okay.
So for us, we know that it sucks through here, so just put this on the edge. This little piece that he's putting on there, I suppose, also helps to not draw resin into the
the system.
Yeah.
Through the pipes into the vacuum chamber filter, or a vacuum chamber. Yeah. Okay, so just using some of the raw material there.
Yeah.
I also see when he stuck this down, it's quite important that we get a seal around the actual vacuum tube.
Very.
So he was using that rubber.
The sealant
tape stuff.
Tacky tape, as it's informally
called. Yeah, it is really sticky. I was handling a piece. Press sticker's got nothing on this stuff. So yeah, he's basically just creating just a little seal around the pipe. Yeah. Well, in this case, he's using the tacky tape to
close off a little piece of
put this breather bleeder over the pipe, and then the tacky tape around the pipe. Oh, this was interesting. So before he actually put the tape on, he kind of just gauged where it was all going to go. Is this kind of something that you always you kind of mock it up first just to see that it's all going to work, or wherever you think it's going to place?
I think the main thing is just to put it in a place where you're going to get vacuum. Okay. So for us, corner seems nice out of the way.
In this specific instance?
Yeah,
with this type of part. Okay. And then he was putting that tacky tape around the tube again, or the vacuum tube, and then sticking it down.
To locate that, as well as to make sure that when you put the actual vacuum bagging on, that it sticks around.
And we can see here that he's actually put that the piece of tacky tape that was put around the vacuum tube that was stuck onto the tacky tape that was already on our sheet, like that the bag's going to stick to.
Yeah, you need that, because if we have any hole anywhere, then
it can't really draw vacuum.
100%.
Okay. So yeah, looking pretty good so far. There is going to be what is this? This
is the actual vacuum bagging. So it's quite a nice plastic that.
Is there anything special about it? Is it just a thick plastic?
It's basically a thick plastic, yeah.
So again, I can go down to one of our local. I'm just thinking, one of our local manufacturers.
I think you'd have to get the correct grade of plastic, but we usually just go to the composite store and ask for vacuum bagging. It's usually relatively cheap in comparison to everything else as well.
Okay, sure.
So if you do have a really complex part, rather give it a lot of vacuum.
Well, as you said, if you don't do this properly, the whole part is throwaway anyway.
Yeah, completely. I mean, you can imagine you trying to run around, you putting the thing in vacuum, especially if you've got a part with a bunch of curves in it.
Yeah.
You haven't given it enough vacuum, and it tries to draw vacuum in and out, you've got a curve like this, but your vacuum bag only sinks like that, then it isn't really doing.
So
doing
does
the
this
job
stuff stretch it all in, or doesn't?
No,
it
you
feel
just
like
want to
it,
give it a lot.
Okay.
In our case, it's flat, so it doesn't really matter. But
Yes, you need to give it enough material to pull into shapes.
yeah.
Okay. So yeah, I mean, imagine trying to save, whatever, 20 or 30 rand on some vacuum bag, and you've got 1,000 rands worth of material. It's not.
It
doesn't make sense.
Yeah.
Okay. It looks like it's a bag. It wasn't just a single sheet.
We get them a lot in bags, and then we just cut the bags open. This one.
So it goes twice as far.
Essentially.
Well, in this case, it goes twice as far. Martin is here, by the way. He's Honor's doing all the work. So
I think I was taking photos. Though.
Yeah, that's right. You were taking photos. So there we go. He's splitting the bag up.
Yeah.
Just to get a single layer. Really.
Yeah, I think someone's taking the. Oh, that's actually me.
Yeah. So what's happening here now?
Basically, we've got that flat, and we're going to start pasting this down. So as we are removing that sort of plastic film from the tacky tape, we're sticking the vacuum bag down. So that's where our bond actually comes through.
And I'm sure we're making sure that it's completely flat stuck.
Yeah.
There's no wrinkles or anything.
If you've got wrinkles, again, you've got a gap for air to escape, and then you might as well not have it in vacuum.
Okay.
Which, depending again on application, whether you do infusion or if you actually even have a vacuum, it really depends on the application.
Yes. And then I see he's doing like sections at a time. I mean, that's just to make sure that you don't get too ahead of yourself. I would imagine. Because once it's stuck, it's
stuck with the stuff. Then you have to end up getting little pieces of extra tacky tape, and it just makes one big mess.
Okay. I need to keep that in mind. Sometimes I do get a little bit ahead of what I'm doing. What else? So he's just running around basically around the perimeter of the part.
Yeah.
That's all that's
Making sure
happening.
that when we switch our pump on,
it pulls the vacuum and doesn't leak.
Yeah, so we get a nice even compression.
Okay. I mean, you can see here that's real nice and flat, no wrinkles.
German precision.
German precision, that's it, eh? He's an expert at his art. So I noticed something he was doing, just I saw this happening, and I didn't want to say anything at the time, but where we've put in that tube, our vacuum pipe, we needed to. I mean, there's a wrinkle now. There's extra material.
So we have to compensate for that.
Okay, yeah. So
what is that? We would get to a point where instead of being able to lay it flat, we're going to have some sort of excess bag where we're actually going to make a little, I suppose, pleat.
Okay.
Something that would, if you want to show that. But
so let's maybe use this. So we're gonna use the tacky tape, right?
Yeah, we're gonna use the tacky tape just to run it in there.
So we're gonna roll up the tacky tape. Well, I say we. I mean, I'm hopefully gonna remember this. We're gonna roll up the tacky tape to roughly the same diameter as the vacuum tube, something like that. Hang on. Come on, focus. Oh, it is focused. So something like that size, and then the pleat is going to be made, as you said, the pleat is going to be made around that.
Yeah, and that again would be on a layer of tacky tape already to make sure that we don't have any leaks.
Any leaks any excess material happening there. Okay, cool. So I was wondering about that at the time.
That's.
I'm sure there's many ways of doing this. This was just one of the ways that he showed us.
Yeah.
Okay. And is this how you normally do it? Before. Well, I say that how you normally do it. I think you learned a lot of your stuff from Arno.
Yeah. At first I used to work on the university solar car and eco car projects for years. So before we actually met Arno, there was a lot of money wasted because we used to try things ourselves and watch YouTube videos and not really know what we were doing.
Oh, sure.
Very experienced and.
Well, is it wasted or is it put down to research? I mean, it's a learning experience
gained.
Yes, yeah. No, I mean, normally, I'm all for working smart and not working hard, but when you learn the hard way or the wrong way,
the lessons stick.
Yes, they stick. Yeah. So, take that as you will. He's basically just sealed an entire bag?
Yep.
Okay.
That's the whole perimeter around, and this doesn't have to be done, but just being very neat about it.
Yes, okay. Well, I mean, I like that type of thing.
Yeah.
So it's, cutting off all the excess material, really, there's less chance of walking or getting it hooked on something and then pull it off by mistake.
Yeah.
So
okay, now you can see the vacuum pump has been switched on. So if we look there, you'll see a bit of spotting happening. So as the vacuum is being drawn, it's forcing our breather bleeder down really against the overly saturated or oversaturated resin, and that's drawing up.
Okay, so all the resin is actually being drawn out of the carbon fiber, really.
Yeah.
For the most part, out of the carbon. I mean, there's what is actually happening where, if we've got our carbon over here and okay, I mean, there's not very tightly knit there, but are we just wanting to basically wet each strand? Is that the point?
Yeah, you're creating a sort of matrix that's got a whole bunch of these carbon fibers in, so we need
and
that
then they just been glued together.
Yeah, and now if there was excess resin, you can imagine a paddle sitting on the top.
Yeah, which is wasted.
Which is
not
completely
strength.
wasted. It's excess weight. It's nothing.
Okay.
It's useless. So, pretend there's peel ply there. We've got the peel ply. The surface finish. That paddle is getting soaked up through there, into this, and it sits in this. And when we finish this whole process, we'll remove the vacuum bag, take the whole part out, and
all the excess is removed.
In the bin, there's your extra weight in the bin,
Okay.
probably in the bin, and we'll have that, which we'll pull off. And in our case, obviously the final product, we haven't pulled the peel ply off yet because we don't want dust to collect on the parts.
I remember, we'll look at that a little later, but that's something I had to get my head around. Like I thought there had to be a certain amount, what I thought way too much, resin, but all that we're really trying to do is just make sure that these fibers don't kind of pull apart like that. They're just gluing together, and that's
interwoven.
It. Yeah, anything more than what's required there is just a waste. Well, and weight. So just to go back here.
Sorry.
As you said, we were drawing the vacuum, and it's just. Is it drawing any of the resin out through the tube?
In this case, no. It's not.
Is that because the correct amount of resin was used for the application?
I think if it was a really, really ridiculous amount of resin that was used, that risk probably exists.
Okay. But then it would just go into the bottom of the vacuum chamber, which was quite a big unit. I mean, it was probably like this big
if I remember correctly, that pump actually had a bit of old resin
inside the
tubing. Yeah.
It seemed to vacuum down quite nicely. Now, did we once it was vacuuming, did we have to run the spatula over the top again, or
we didn't? No,
we just let the vacuum do its job.
Yeah, with our situation, just because it is a flat part and we've got the whole breather bleeder, which allows the vacuum to distribute evenly across the whole thing, we didn't need to.
We said if we didn't use this breather bleeder, then what would happen to that? I mean, if we just put on that perforated sheet, I don't even know where it's gone now. It's probably on the floor somewhere, but don't worry about that. If we just put that perforated sheet on and no breather bleeder, what happens to the excess? Because it will still draw through the perforated sheet.
And then it would probably be sitting on the top, and it wouldn't draw as nicely as that. And it would then bond, probably what you'd be sitting with a lot on.
Okay. So it's just rather use this. For the extra cost, it's worth the result.
Yeah, very much.
As for the amount of vacuum, we weren't you're going to draw more vacuum than what you can suck with your mouth, basically.
Very much.
But what were we drawing over here? Let's try and get to that.
280 millibar.
So that was in inches of mercury. That is looks like 21 and a half inches. 21 and a half inches. I'm just trying to think what that is in terms of. I can't work that out now. Anyway, it doesn't matter. I'm just trying to relate it to what I was, my actual job. But so you're drawing in inches of mercury there, roughly 22 inches, or as you said, millibars.
Yeah, 280.
280.
I think we got. That's no number. I think it's just what the pump was probably set to. It works for our.
So and it worked in this case. I mean, are there instances where you need to pull a much higher vacuum? In what you've done. I mean, I don't know.
In what I've done, I think basically this 280 millibar has worked.
Okay, cool. And what happens if you don't have a vacuum pump at home? I mean, any ideas on how you can
Well, you're either going to get a part where your excess resin, I suppose, might not be removed properly, or you borrow one.
Sure. So in our case, we did actually borrow one from another part of the university, actually.
Yeah.
Look, I mean, I suppose you could modify an old compressor to. I don't know if you. I mean, I don't know if you can. You probably could.
Again, I think it depends on what your budget is.
Yes,
You're gonna play with the old compressor, you might be able to just get an old vacuum pump. I don't know. It depends on.
Yeah. So, mate, go and shop around a little bit. I think that was the end of that. That's it. We just wait for it to cure now.
That we waited for, yeah. So we waited. We left it for 24 hours. In reality, it depends on what hardener you've got. Sometimes it's usually good within a few hours, and also depending on your application, even the next morning. I mean, it's great to come and take it out if it's a really hectic part. You can always heat treat it afterwards as well, so bake it in an oven for X amount of time to actually really properly harden it, and that can also increase the strength a little bit.
This is something that I wanted to ask. Now, I don't know if you know about this, or if you've got any experience in that. But sometimes when you use, or not sometimes, it happens all the time actually. When you spray a car with base coat and clear coat, and you spray the clear coat on, that takes a long time to get hard. I mean, after 24 hours, it's hard.
But it's not 100% actually.
But it's still, it's not tacky, but it's soft. I mean, after a week, this happened to me again because I forgot about that.
Yeah.
I sprayed up a pot a little while ago and left it lying on the camp bed, and it didn't stick to the camp bed. But now
you pull it away and the paint's.
Well, you can see the what do you call it? The texture of the camp bed now is of the canvas, should we say, is now on the pot. And I mean, that was before I put it on there. It was a week already. Well, not quite 5 days. So in that case, I think before you polish a car, if you really want to get a nice good finish, you wait weeks before you really put a good a flatting polish on the clear coats. Is that something that happens with this type of resin, or is it when it's at 24 hours, that is it? It is hard.
No, you can still bake it in an oven for a little bit afterwards.
So it will get harder over time. If we wanted to say, let's say we got our glass.
Look, it should be good enough to use, but again, depending on the application. Sure. I know we made wheels a few years back, and that we took out and we put that in the oven to make sure that was 100% fine. But we've also made things in the past when I was on the EcoCar project, just say a little cover for a duct or something that's not a really load-bearing structure. That didn't really make too much of a difference if we did or didn't.
Sure, okay. And then, as part of the finish, if you wanted to, if it was on glass, and, you got this nice shiny finish, and you still wanted to polish that, is that what you're saying? Like, you rather let it get old or cure over time, and then polish.
And then you can clear coat it and polish it, or polish straight, or whatever you want.
But from my experience, when you cast something on a nice smooth piece of glass, it's really a good finish.
Yeah, you should get a really nice finish out of it. Maybe, I suppose, if you've pulled too much of a vacuum, you could have a few pinholes or basically areas where you don't have enough resin in, and that would mainly be in between the little fibers. You might have one or two.
Like when you hold the sheet up, you can actually see the little holes.
Areas like that, if you can imagine there's no resin there, so then your clear coat actually might, but then I suppose that's more of a cosmetic.
Yes, a cosmetic thing
as well.
Where in our case or in your case, should I say, this is purely scientific for test purposes, really.
Yeah, this is just a university prep. We're going to make some tensile samples, and if we didn't, I said no, this is going to be stored in the workshops. There's a lot of dust and all sorts of stuff going, so we've still got the peel plow on, but these will be cut into samples, and just before everything's bonded, we'll actually just pull the peel plow off and throw it in the bin. But in our case, if we didn't have the peel plow, then we would probably have to sand little edges of the samples, because when we put that into the tensile machine, it can actually crush. So the standard sort of suggests that you put tabs on either side just to sort of dissipate your stress a bit.
Okay, sure. Luckily, I won't be testing anything. I test it while it's happening. If it breaks, then it wasn't strong enough. If it doesn't, then it is strong enough.
Yeah, that sounds good.
But so we've actually got the finished product here. I mean, it's quite a big sheet.
It is.
It's as Martin was saying, that's there. So let's flip it over here.
That's the better side. That's obviously the part that was against.
Yeah, we're probably going to get quite a lot of reflection. I'm going to see if I can get a close up here. There we go. So as you all know, this is kind of the carbon fiber that you would. That everybody knows, except for the lines. You can see those lines. That's the peel plow.
That's the peel plow. That'll come off.
When you're ready. But I mean, this was cast on a piece of Perspex with its protective sheet on.
Yes.
And it still came out really, really well. So I can just imagine on a big sheet like this on a well-prepared surface is going to be excellent. If you don't put this down,
your release film, then basically you've got your. Where's the peel plow?
So this is an interesting part here. Have a look at that corner there. That's not going to come off. If I try and pull that off, there's no ways that's actually going to come off, and that was because of this.
Yep.
This piece of perforated release.
We've tried. Yeah. No one. We've had it.
It won't come off. So don't forget this. And that's what that little right hand corner was. Arno was just showing us what happens if you do forget. You do forget some little items. So. I just want to just check your little notes. I've taken notes here. I can't remember everything. Usually I do, but today I didn't. With the sealing tape. So, I mean, you buying it from the correct manufacturers and suppliers, but can you use double-sided tape? I mean, does that work? Foam
It's not going to be as great. I don't think you're going to pull a proper vacuum.
Okay, because that'll leak. You might
you're
leak
going
through
to
the foam
or
tape.
something. I think a double-sided tape is generally usually a foam sort of
like an open cell foam, basically. Okay.
Yeah.
So the resin, we talked about that, mixture, paintbrush.
Resin, obviously in our case we used epoxy, but again it depends on the application. So it depends on the temperature that the intended part's going for. So you get different types of resin.
Of resin, yeah. Look, I think mostly for the stuff that I'm going to be doing, and for most of you when you're trying this at home, probably the cheapest resin is just the best to go for. You don't need this high heat.
Yeah, depending on what your if your part's going to be operating at 800 degrees Celsius or something, then different story. But
on a Formula 1 car, which is never coming out. We're not making one of those. This is carbon fiber that we're using. Can we use the same process to like with a glass fiber sheet?
Definitely.
So exact same thing?
Any composite, whether it be sort of your natural fibers or whether we're looking at something like Kevlar even or...
Oh, nice. Okay, that's something that I haven't played around with much is Kevlar. I take it's also expensive, really.
Yeah,
it's pretty expensive.
Well, it again depends on.
Well, yeah, what's relative, you know what I mean?
Yeah.
For home use, it'll be expensive.
Yeah, for home use.
So something also just to end off on. I mean, this was made under not under ideal conditions, almost under ideal conditions, if you want it. Well, not really. It wasn't really a controlled environment, but. Compared to making it at home in your garage where you've got, not really everything at your disposal, if we wanted to make a rough and ready, cheap and nasty carbon fiber sheet or glass fiber sheet, of course we could just go to the hardware store and buy, fiberglass or fiberglass sheet.
Can even be that, sort of chop strand.
Okay, yeah, that stuff I've seen that. Oh, that stuff's terrible to
it is.
I hate that. But you can buy the sheet, and then peel ply. I mean, can you use maybe material, or is this like you need?
I've
peel
never
ply?
tried using the material, so I would generally try to
to
get the proper.
Look, if you're going to try this with material, this looks like it's not a cotton material; it's a nylon.
Yeah,
it's a nylon type of material. So thinking about it now, I would say as long as it's smooth and it's nylon. It probably will peel, but...
Maybe it's something to experiment with. I don't know.
That's true. But also do remember... oh, no, sorry. I might have got this wrong. The release agent that we used earlier, that was the spray-on, that release agent was put onto the outside between the glass, or the Perspex in our case, and the peel ply.
Yeah, that's, I think, possibly one of the most important steps. If you don't...
So then that goes to say that the peel ply, it's only releasing because of what it is, basically. I mean, it's made to peel off. You're not spraying this stuff between the peel ply and the carbon.
Well, if you didn't have the peel ply in this instance, then you just did that, it would still release. But if you didn't have that release agent, then you'd be stuck.
Okay, so we don't have to use peel ply.
No, like again, in the beginning, the only reason I put peel ply on both sides is just to have a sort of
that rough finish. Yes, I remember that.
Finish, but you don't have to. We don't have to put peel ply down before we put carbon down.
Okay, so 2 pieces of glass, release agent, and then some just carbon fiber or fiberglass sheet, some 2-part resin epoxy, whatever you want to call that stuff. I mean, that's all stuff that you can get at your local hardware shop, really.
Yeah. And
the spatula we kind of talked about. And if I remember correctly, that's how I made this, and it came out. Look, I mean, the surface.
It's not bad,
it wasn't bad for. I knew absolutely nothing 10 years ago when I was doing this. I didn't watch any YouTube videos. I mean, now it's all over the place. It came out quite well. I mean, of course, the piece that I made was this big, and it still works today. Not that I really use it anymore, but it was very strong. So it is possible to do that, as we said, cheap and nasty. If you, I suppose, want to prototype stuff, maybe.
Yeah. It'll work.
Yeah, it'll work. Anything else you want to add? I mean,
I'm good from my side.
Yeah, it's been quite a nice experience to be able to see this before I actually tried it at home, and hopefully this video helps you in when you want to try stuff at home by yourself. So thanks for watching, and if you've got any comments, leave them in the comments section below. It'll be nice to hear from whoever. It doesn't matter. Maybe you are an industry expert and you're pointing out that we're doing something wrong. Then keep the comments to yourself. No, no, I'm only joking. No. Any comments are welcome. Both good and bad, not a problem. So leave us some comments. If you haven't subscribed to the channel, please subscribe. It really does help me with the channel. So it's a good motivation. And yeah, we'll see you in the next video. Thank you very much, Martin, for joining me today. I mean,
Thanks for having me.
it's been almost an hour that we've been sitting here just, shooting the shit.
It's been fun.
Cool. We'll see you next time, guys.
Cheers.
Cheers. That's it.
Yeah, that was wonderful.
Dude, that went